What is up, everyone? I am hoping that you're good. I've got another laptop here to work on. This is an HP Elitebook. I believe it's around 7 Gen. So that's nope, I can't see. Anyways, it doesn't matter. Anyways, the laptop doesn't switch on. Dead. Nothing. I am going to apologize for my desk. It's a real mess. Been making a lot of stuff. Anyways, when I plug a charger here, no life, no response, nothing. Looking at the power supply, it's drawing 0 amps, nothing at all, no response. So I have to check out the motherboard from the case and see what's happening. I've been trying to look for some liquid or something like that. Yeah, I'm trying to sniff if there's been any liquid poured on it, but I can't tell. I can't see anything. So I'm gonna pause the video, check out the motherboard, because I don't want this thing to be too long, and then I'll resume. Cool, so this thing is out now. That was the last rip on. What do we have? Yep, we've got liquid. We have got liquid on this. I'm not sure how bad that is, but yeah, it's definitely there, as you can see over there. We're now getting corrosion all over this area. So this liquid came in from under the speakers, yeah, just above the keyboard. And if you look at the EC now, this is the tricky one. If this one is corroded, yeah, we might be in some trouble there, but I'm hoping it's not. So what do we have here? I think we can tell we've got our charging port, first coil, first MOSFET, second MOSFET, current sense resistor. The rest I don't really need to know. So these are probably the MOSFETs for charging the battery, although the battery connector is way far away from there. I don't know. Anyways, underneath those two MOSFETs there is this coil, so it might be related. What I'll do is I'll check for a shot and see if that corrosion has caused a short circuit. Nope, we've got like 23 kilo ohms. 46, it keeps increasing. No, that's fine. Let's check this one. Let me kind of zoom out so that we can keep everything in focus. This one is giving us 6 ohms, of which it's headed to the CPU. That's okay, 16 ohms. That's fine. That's for the battery, 8 ohms. No, it's not for the battery. Which one is for the battery then? Give me a minute, someone is trying to open my door. I don't know who that was. It's pretty late now, almost 9 p.m. I'm hoping it's not someone who was trying to steal. Let me just check the car outside. I'll be back. Okay, seems like everything is fine. I just don't know who was trying to open my door. So this one that I was thinking is coming to the battery, it's not. It's going to the CPU. As you can see, there is a trace just there. Yeah, so you can see the trace coming to the CPU. So that's not for the battery. I'm just wondering which one is going to the battery then. Yep, the one that's going to the battery is the one that I've started by testing. When I say those MOSFETs are for charging the battery, it's this one. So if I probe from the battery connector there, let me zoom out. From the battery connector we come to this one. Yeah, that's the one. So those MOSFETs are for charging the battery at the end of the day. So what we'll do is we'll work on those. I don't think we have to even remove them, probably just have to reflow them. Let me just check those caps around. Yep, there's a short here. There's a short around these capacitors, so I believe it's a short in the main power rail then. Yes, it's in the main power rail. So first MOSFET, second MOSFET, main power rail, which means those two capacitors have caused a short in the main power rail. What we can do is we can inject voltage, although we already know where the issue is. But yeah, I don't think I've recorded myself injecting voltage in a while now. So let me just do that. So using a cat phone thermal camera, where is it? My flare. It's loading up. Okay, there we go. Let me try to keep everything in frame. So I will inject voltage over here where the main power rail begins. So let's go. Yep, you can see the spot there. 80 something, 90, 100. And when I don't know if you can see, it's even smoking. It's smoking. Yeah, right over here. I'm sure I can remove these without using a water station. They are boiling themselves away. I've done that somewhere before. So you can see how they are treating, what they are doing to the flux there. And it didn't work this time. I'll just remove using hot air. And I just noticed that my soldering iron is off. Turn it on now. So I'm not sure which one it is, but I'll just remove the two of them. There's no need for me to keep them there. There we go. They are off from the motherboard. And when we check for a short, it's gone. Negative, positive. So this is the positive that comes to the main power, which then charges the battery. So yeah, I'm not a fan of keeping things like this on the board. I'll just remove these MOSFETs as well before they cause trouble. Then what I'll do is I will clean the area around, even though I don't need to. Where's my alcohol? I don't really like this alcohol. It's from Baku, but then it's just like water. I don't see how it's useful. So I'm cleaning the entire area where we were getting the corrosion max from. Alright, so these don't matter. What I'll do is I'll get a donor board. I think I've got donor boards on my desk here. Quite a few of them. Which MOSFETs are for charging a battery? No, this one doesn't have that circuit. It's got a dual MOSFET, it seems. Get another one. Okay, here's one over here with two MOSFETs. So I'll grab the MOSFETs from here. I don't think it matters which one goes to the low side though. But just for interest's sake. Low side, high side. And then on our board here, low side, high side. So yeah, it's pretty easy and straightforward. What I'll do though is I will sort of add low melt solder to the pads there, so that these components I'm gonna put here don't Don't give me trouble to sit. I need to change the tip of my soldering iron now. I used it to bend plastic, something that I never do, that I always advise my technicians against, because it ruins the tip of your soldering iron. It no longer distributes heat the way it's supposed to. Anyways, when we bring in the hot air, everything will melt away. So this is our low side MOSFET. Oh, I need another tweezer. This one will do. Okay, low side, high side, 2 caps. Alright, here's the high side MOSFET. It sits like this. So it's always wise to reduce your airflow when it comes to this. As you can see, I've got components flying off from the motherboard. The 2 caps. And then the diode. So that's most likely a dual diode, whereby you've got would it go as a what? It's an OR gate, I think, where either of the two have to be present to get an output. Usually you get this type of a double diode or OR gate when you are dealing with the power that goes to the charging IC. So it would have power coming from the battery to activate the charging IC, or power coming from the charger to activate that IC. Okay. Alright, I guess we're okay now. I'm just trying to make it look nice and neat, otherwise there's no need really. Cool. Let me check for a short again before I plug a charger. We do not have a short. We've got 61 kilo ohms coming here. We don't have a short. We do not have a short. Okay, what we'll do now is we'll plug a charger and see if we will come to life on this Elitebook. This is a Core i5 7th generation. In this part of the world, it's still a valuable laptop. In some parts, it's still a gem. Yeah, and then in other countries, it's e-waste. So now we're drawing 460 milliamps. So yeah, this thing is up. If you can see the LEDs over there. Come on, focus. So I've got the LEDs there. We're drawing 290, 300, 320. Yeah. So I will take it off from the charger and connect it to the casing to try and get display. We do have a RAM memory stick over there, so we shouldn't have a big issue with display. So I don't really need to plug in everything. I'll just get a display port, display cable, and a power button. Then we can plug the charger again. Okay, I've got fan spin, and then it stopped, but it was still drawing 500 milliamps now. So we got, yeah, there we go. HP post error, wara. This is fixed, guys. Anyways, I hope you learned something. As always, I will see you in another video. Just a recap of what we were dealing with. We were dealing with a case of liquid spill on the motherboard, which caused the two capacitors around the charging MOSFET for the battery to fail. Then those two MOSFETs also needed to be replaced. Although we didn't check to see if they were working, we just replaced them as well. And now the motherboard is working. Anyways, I will see you in another video, guys. Cheers. After cleaning this up, I'll put it back in the casing. Bye for now.